Hello and welcome to the Tech Lunch podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listener's ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
And this week we're going to kind of touch on an episode we did a while back called Requirements Gathering. However, this one we're going to kind of take a different approach to it, and we're going to look at software testing. And we're going to look at it from a holistic approach. So we're going to look at it from what it is, what it's used for, and everything in between. And, that's how, funny thing is how I got into IT was, starting with software testing, going from a waterfall approach down to a agile approach, kind of back to a project management standpoint and back into a waterfall, agile, methodology approach. So, when we're talking about, I guess you'd say, software testing, Ed, kind of what are you thinking when you start hearing that?
So from the OT side, we would normally be exposed to these things via PLC programming. And in PLC programming, just like when we were talking about requirement gathering, we would gather the parameters that are necessary for the program. Then we would start a design phase after we figured out what the requirements were. For example, if it was a conveyor, do we need an entry sensor and a exit sensor? And then we would go into the build process. Mm-hmm. And after we built the program, we would do testing.
Yep.
After testing, we would deploy. And this is a waterfall approach. Right. This is probably what's been done over the last 50 years. This is probably what's been done.
Yeah, waterfalls are more common. However, as you're getting into things, you start dealing with, like Microsoft Teams Foundation Server, MTFS, and like HP's all-in-one testing center. But sure, you start moving into more of the agile approach as we've gotten into things. So I think agile is kind of taken over from the waterfall standpoint, and with that, you're kind of talking about like your user story creation and stuff like that, and testing through your requirements. That's why the requirements gathering is so important on any facet of building and deploying equipment, or even deploying software for that matter, because you start dealing with like IV&Vs and UAT testing and verification testing and stuff like that, black box testing, white box testing, and automated versus manual testing. So when you're thinking about that, kind of what are you thinking about?
Well, this is where I think you would use a 10-minute test plan. And then we would look at things like the attribute, which would be like the adjective. So if it's a conveyor, will we have a fast or slow speed? Then we start looking at the component, which is your noun. Is it controlling motors? Is it controlling variable speed, variable frequency drives? Is it controlling sensors? Mm-hmm. And then we would look at capabilities, which would be our verb.
Yeah.
What do we want this conveyor to do?
Like a capability test.
Yes. So that would be how, from a PLC perspective, you would approach it from those type of things. And then, you would even do some functional testing.
Yeah. So like regression testing and stuff like that when errors are found. And it kind of like when you're talking about the, the code building and stuff like that, and the testing, especially on a conveyor standpoint, you're talking about more manual test, bug fix, stuff like that. You're looking for, these type of issues and stuff like that kind of pops up out of the blue. And, that kind of rolls you back into the verification phase and the verification steps and stuff like that you're dealing with, or the IV&V, internal verification and validation testing. You start looking at things like kind of what NASA did. If you think about it with the Artemis program, that just rolled out this past week. You're talking about moments in time of where you have to do an IV&V on this equipment. Validating this equipment works with each other and stuff like that. It's all the different stress testings and stuff like that. That can still all be considered software testing because it's software attached to hardware.
And then, from another perspective, we talk about syntax errors. So when we're talking syntax errors, we're talking about errors inside the program that do not follow the rules of the programming language.
Yeah, exactly.
For example, if you're using Siemens Step 7, you do not add the right assignments for operators, or you don't add the right characters to denote in STL what you're doing.
Right.
The other thing is logic errors. We're talking about errors that are logic in the program that cause it to behave not as intended.
Right.
So, for example, maybe we were supposed to multiply something and we divide it.
Exactly.
So we don't get what we expected.
Yeah.
And then the last thing is runtime errors. So runtime errors, we're talking about errors that could cause the program to execute or crash. And these are things like writing to the wrong memory space.
Yeah.
Dividing by 0. So things like that is you really have to be diligent about these things because you got machinery moving and things could crash and you could tear up equipment.
Right. And then we start getting into what is software testing in the grand scheme of things, and we start talking. You hear us talk about Waterfall. What Waterfall is build to the requirements and test once it is complete. Then you start dealing with Agile, which is a rotational testing methodology where you test as your code becomes available. It's a test and release standpoint, and then you start getting into manual testing, which a lot of people call button click testing, because you pretty much click the screen and play with it until it breaks, record your errors, and then go back and fix it. And Agile, we kind of let those go if they're not priority 1 or 2 bugs. They're only like pri 3 or pri 4s. However, in Agile and Waterfall, that requires a rewrite. And then you start getting into your automated testing, which is something that we've touched before on the OT standpoint, is where we kind of use a system to test another system. And, that's when you start getting to like stress testing of the code to make sure the code is correct. But, the thing is that's also when you think about it, that's when we go back to the priority numbers that you heard me talking about, the priority 1, priority 2, priority 3, and priority 4. Priority 1 is a full stop. The system cannot progress any further past that point. It is a complete and utter breakage. A priority 2 is a issue that requires a workaround for functionality to exist. A priority 3 is something that's just a little bit uncomfortable. Priority 4 are your spelling mistakes. And this is, kind of, if you think about it, I guess where Windows lives. They live in the priority 4, realm of things because they can handle that type of stuff without having to push out a new release. So, when we're talking about like priority numbers and stuff like that, what are you thinking about?
So for the PLC and from the OT side, safety is obviously the major concern.
Safety is key, yeah.
Yeah. So if you have a safety program, you have a basic program and then a safety program. So you do all of the standard program. You do all of your normal control in the standard program, but inside of the safety program, you isolate the two. They're in layers. So it's in 2 layers.
Exactly.
The safety program is supposed to be isolated from the basic program so no one can just make changes. The other thing that is really a big concern is how we program and reuse function blocks, reuse data blocks, reuse function blocks and functions, and also we make sure that when we're doing our DBs, we assign certain areas in the DB to certain things. So you basically compartmentalize your code. So basically it's reusable and it's easy for the maintenance personnel to use it. And then I would say probably the last thing that everybody should do is documentation.
Yep.
Make sure you comment so people have a clear understanding of what's going on inside of the logic. It does no one. It does a disservice to everybody if we make this code where nobody can understand it but the person that programmed it, which will not be on site to maintain it.
Right.
So the people that are maintaining it should have a clear understanding of what it does.
Oh yeah, the release notes. Release notes are a great thing, and that makes me think that the OT side of the house is using more or less an agile methodology, and not using a waterfall break fix. But that kind of rolls back or rolls forward into your test management side of the house. When you start talking about test plans and test steps and stuff like that. When you start talking about test steps in the grand scheme of things, it's, I'm going to open up, say, Microsoft Word, for instance. I'm going to open up a new Word a new Word book and, start typing. Each one of those steps, I would document and say it's a pass or a fail to say if that actual thing passes. However, I'm testing to a requirement that states the system shall have a word processing software built in. It doesn't tell you what it is. It just says it has to be there. And then with that, we go back and we look at the test. That ties to the test management aspect where you're building your test plan. You're setting up your test schedules. You're setting up your test members, your environments, and everything else. And with that, every person who is testing has a particular job. It's not that, Joe Schmuckatelli is out there just testing this one thing. It's kind of you're testing little by little, little by little, little by little. However, everybody has, cool, you're going to get this application or that application and go that way. Kind of, I guess, in the OT standpoint, you get this one line, this other line, and this other line, and you kind of tell me if it works or not at the end of the day.
Yeah, and there are different ways of programming, just like there are different software packages you can use. There are different methodologies you can use. So even with like PLC programming, you got ladder diagram, which is more of a graphical, easy for people to understand and follow.
Yep.
You have function block diagrams, which is almost like following digital logic, digital gates. And then you have STL, which is, structured text.
Yep.
And basically what you can do with these languages, each one has strengths and each one has weaknesses. Most of the time, most of the programming is done inside of ladder logic. Some things have to be done in STL. Calculations are easier in PLC languages in STL. And most of the time, function block and ladder logic go back and forth. They convert. But one of the biggest things when we're talking about testing, you have to simulate these programs.
Right.
You have to simulate inputs coming on and off.
So like an automated testing standpoint.
Exactly. You have to kind of semi-auto. It's kind of in between, but mostly automatic. Mm-hmm. You have to simulate sending telegrams. You have to simulate sending bits of data or whole words or converting a string from a string into an integer.
Yeah.
So those are some of the things that you encounter with PLCs.
Now, with that, it leads me to this question. In software testing, we do something called code review. We look at the code as we're running the program to validate that the function is working as it should. Now, you're talking about how every little bit of this PLC requires a code standpoint, right? What type of code review do you guys go through for say a PLC change or a new program addition? How do you guys go through your software or your code review process before that can actually be implemented for test?
So the first step is we have to have the requirements gathering. We have to have the parameters. That's the first step. The next step is once you have the parameters, you would do some type of Q check. And with a Q check, you would basically take and say, here's the parameters, or here's the standard that we're going to go by. Anything that's outside of the standard, naming convention, using the right area in the data block, making sure that we're tying a FB and a DB to where it's supposed to be, making sure we don't have bits in there that are always on or always off. Those are things that you would do a check for.
Right.
But ultimately, with PLC, someone still has to do a spot check.
That makes sense.
A human still has to go and say, hey, some of it has to be done manually. We're
Right.
not at the point with AI that we can do these things, so a human has to make that adjustment, especially with safety.
Yeah, that makes sense. And the thing is, in like the software standpoint, on the IT side or, the server side of the house, we look at something, and also we look at the what is called the definition of done. Is this story complete? If I cannot test to it, the story is not completed. So that's an agile. So it's an agile approach. Is it done? If you're looking at a waterfall standpoint, you're more or less testing your requirements until you run out of requirements and test to. So, on like a PLC change type of thing, I know what my definition of done is, but what would be your considered definition of done when it comes down to, running into the end of a project or end of a user story? Because if you're talking about from the agile methodology, you're talking, requirements to user stories to test processes and code. So what is your definition of done?
So with PLCs, it's a little different. PLCs is living software. So what I mean by living software is that the user experience is always going to dictate if some added features need to be added. And you won't know that until the user has, until it's been deployed to the field and the user is working with the equipment. The other thing is optimization. There will always be optimization with PLCs and factories because we may have one set speed.
Yeah.
And then later we may have to say we have to run at a different speed.
Yeah.
So these are some of the things. And then another thing is you'll find that in the logic that it's something that an operator or a human can do that you didn't expect. So you'll get some unexpected behavior or bugs.
Yeah.
So you'll be fixing bugs.
Additional features.
And then lastly, you'll see some things that we didn't have in our parameters. So we had to make Pokio systems.
Yeah.
So it's a little bit different with PLCs because it's a living software. So it's never done with that system until you convert over to another system. Then that system's done. So because most OT environments gonna run 10 to 40 years before they make a change.
So you're saying you got a lot of unexpected features. And, with that, you kind of get into your UAT standpoint. Like what you said, you have to wait for the user to do something, to expose, said feature, because, a bug is considered a feature if it's lasted too long. If you haven't fixed it yet, it now becomes a feature. It's a permanent feature. So, which kind of, brings me to a standpoint of, I know we use UATs to test massive rollouts. We'll bring the customer in and bring in a couple other things, and we'll sit people down at a terminal or at a PC or something that we have that we're using, that we're writing it on, and say, do your job and let us know if this is what you wanted originally. So from the OT standpoint, when you talk about UATs, we do them routinely during every major release. Now, I know that you said it's a living document. Do y'all do major releases that require UATs?
So now there's always updates to the actual hardware that you have to consider. Unless you employ a system that freezes the version and we say this is the version that is most stable for us and we're going to lock in this version. We're not going to go higher than this version.
So like a version control.
So we do have version control. But the thing, like I said, because it's a little bit different with, like, say, a programmable logic controller. For us, we get a process map, or we get a process engineer tell us these are the steps that will happen between the human and the machinery. So human to machine interfacing will be this.
That's a scary thought.
And until we get to a point to where we can say this is no longer a human machine process. It's the human is unpredictable.
Right.
So this is why I mean it's a living program. It will always have to have some adjustments.
Right.
Because we don't know what new feature is going to be needed.
Right.
So from that point, yes. But you can take data from existing plants or plants that came before or lines that you decommissioned and say, hey, well, we did this last time. We had this problem. So what you do is you carry that stuff forward to the next program.
Right.
So you already know that you're going to have these features, and maybe what you do is make the feature dynamic. Maybe I have an entry box to say, hey, I want to run normal, I want to run in degrade mode, and I want to run in commission mode. So maybe you have the option to do that.
Makes sense. So what now? This kind of brings me to a kind of a point here. It seems like as the software testing standpoint goes, from an IT standpoint to an OT standpoint, they're one and the same. Just at a different piece of equipment. And then you kind of see that kind of expand more in your engineering standpoint, where you're doing this, IV&V and UAT and stuff like that on bigger piece of equipment. We've seen it in, space flight. If you think about it, it's like what you and me were talking about earlier. Software testing started with Mercury, with the Mercury space program. That's where it got its start and its kick. And, I'm utterly familiar with that process, but it also became the first time we've ever done an engineering test on a human space flight, which pretty much what that was the UAT. If you think about it, John Glenn's three orbits around the Earth was a UAT test. For us to go to Apollo, and then from Apollo to the moon, and then from space shuttle on. However, with the new advent of Artemis and the SpaceX type of thing, you start dealing more and more with older testing scenarios. Now those testing scenarios become real. And that's why we're launching the unmanned uncrewed rocket to the moon for Artemis 1 to do that testing. So if you think about it, software testing itself has kind of moved from the button click world of IT to the PLC world, and then onto the the space flight world, where it actually came from there and now going back. And vice versa, depending on what version of engineering you're in. So, I don't know if you see the same light that I do, but, that's just my opinion.
Well, I see in the future of programmable logic controllers, we're going to go. So we went from PCs in the industrial environment, being interfaced with inputs and outputs, to where we combine those into one box, PLC. The next progression I see is opposite. I see PLCs as a service.
Yeah, I can agree with that.
I see Python scripts running on PLCs, and that's where I think we will end up ultimately. And as always, we appreciate you guys listening, and thank you for all the support.
And I'll end it on this. As we see things change, as we see things evolve, it's time to really, get involved in this. Sit back, learn it. If you have any questions on, any of the software testing stuff, we'd be more than happy to give you a hand. Point you in the right direction. Get involved, learn Agile. Learn what it is about Waterfall. We hope y'all have a good night and good afternoon, or whatever time you're listening to us. And we'll catch you on the next episode. So catch you around. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast at vulcanara.com. Hope you have a good rest of the day and continue learning.